All right, ladies. Sorry I'm not there today. I'm going to go ahead and do a video recording like I did at the beginning of the year. Today we're on day 4 notes of chapter 3, direct variation. Direct variation is described as an equation in the form of y is equal to kx, where k does not equal 0. The equation illustrates a constant rate of change, so the same thing as a slope, but k we consider as a constant of variation. It's also called a constant proportionality. So literally, the rate of change and constant variation are the same thing as slope. They're all the same exact thing. So a direct variation equation is a linear equation in the form of y equals mx plus b, where b is equal to 0. The constant variation, I said, is the slope. Because b is equal to 0, it's always going to go through the origin when we graph. So here, what is the constant variation, or the constant of variation? So I can say k is equal to 1/4. So we definitely know that the slope is equal to the same thing as the constant of variation. So there will be a question on your homework just like this, is saying, why don't you relate the constant of variation to slope and to the rate of change? So if you were to graph this, we start off at the origin, right? And we rise 1 and run 4. And then we can go backwards, down 1/4 as well. Okay? And yes, you'll do some graphing. It'll say show your answer, so it might not appear to be correct until I enter it to be correct. So we're going to actually come up with the equation for a direct variation. Suppose y varies directly as x. When we say that, it's like suppose y varies directly to x. That k is telling us that it varies directly, okay? And we're multiplying the x variable by a constant k. And so we're going to write a variation equation that relates these two variables, x and y. So here they say when y is equal to 14 and when x is equal to 3.5, use the equation to find x when y is equal to 36. So I have to solve for my k first. So we would have we have y equals y, right? Oh, wrong y. X is equal to x, and we plug in as so. So y is 14 is equal to k times 3.5. Okay? And then if we solve that, okay, I believe is 4. And you should also have your calculators out, right? So k is equal to 4. So my equation of, I want you to write the direct variation equation. Y is equal to 4x. And then it asks us, use the equation to find x when y is 36. Yeah. Okay, so then we would plug in 36 to y. So 36 is equal to 4x and then divide. X is equal to 9. So informative, I have it as y is equal to 4x semicolon space 9. Okay? It's a space. I don't actually have like a underscore there. I have a space. Okay? So if you're like, it's still wrong. It's still wrong. If you feel like you've done it right, I will go back and check them. But that's the formality I have for most of these problems. If it asks you to write an equation and then solve for another variable, this would be the form I have it in. There might be 2 parts too, so we just have to realize that. Okay, so let's try another one. Same direction is that y varies directly to x. So I plug in y, I plug in x, we divide by 16, and I believe k is equal to 9. So my equation is y is equal to 9k. And then it asks us to find y when x is equal to negative 6. So that's easy, right? So y is equal to negative 54. So informative, I'd have y is equal to 9k semicolon space negative 54. And no, I don't have y is equal to negative 54. I just kind of have what y would have equaled because the question asked specifically what y would equal to. Okay, not so bad. Excuse me. I sound probably kind of stuffy right here. And hot air balloon's height varies directly as the balloon's ascendant time in minutes. We're going to direct variation for this distance, d, ascended in t time. So we know that the height varies directly with time. So height is the distance, so d varies directly with time. Okay, so then I go over here to this nice little picture I have, and they say that in 5 minutes is 350 feet. So I know that 350 is my distance. I don't know my k, that's what I need to find, and my time is 5. And then I divide by 5. So k is equal to 70. So my direct variation equation would be y is equal to, not y, d is equal to 70t. We got to follow the formality of those variables. So that's specific in this specific section is that we're going to have variables that we're going to not have besides x and y that we've been using. Estimate how many minutes it would take to ascend 2,100 feet. So when will the height, the distance be 21 feet? So here we're plugging in for d, right? So d is equal to 70t. D, they say, is 2,100. 70t, divide by 70. It's a little chicken scratchy. So t is equal to, looks like we have 30. Wait, yeah, 30 minutes. Okay? About how many minutes would it take to ascend 3,500? Same idea. I would plug 3,500 into D and solve. Those cancel out. 350 divided by 7 is 50. "50 minutos." What do we call that? Trying to think of that in Spanish. 40. No, that would be 50. That's right. The wavelength, lambda, of a wave of a certain frequency varies directly as the velocity of the wave. So we know the wavelength varies directly with the velocity. So we always have to typically find K first. And lambda equals, or the wavelength equals 60 feet when the velocity is 15 feet per second. So we're going to start off with that to find our K. Right? So we have 60 feet is equal to, we don't know what K is, and our velocity is 15. And then we solve. So K is equal to 4. So I know that lambda is equal to 4 times velocity. Find the wavelength when velocity is 3 feet per second. So we just plug in 3 feet to velocity. "12 feet would be the wavelength. And I don't think on the homework I put any fun symbols there. Write a direct variation equation that relates the variables in the given graph. So we also know that, here we have gallons. So I'm going to label gallons with a miniature, a lowercase g. And then cost, I'm just going to put it as a capital C. So I know cost varies directly with the gallons of gas, right? So then I know that K represents not only the constant of variation, but also represents the slope or the rate of change, right? So here I can find my slope and just plug that in to K, or I can find some nice point on the graph. So yes, I have 0, 0, but that's going to do nothing for me, right? So then I come and find another nice point right here. And this point is 4, 12. And I know that that's G, capital C. So I can plug those in. 12 is equal to K times the gallons. Divide that out. K is equal to 3. So if I were to write a direct variation equation, and yes, I want you to use variables that make sense. And normally, I believe I told you in all of your homework what those variables should be. So the cost is equal to 3 times the gallons. And if I were to interpret that, I could say that, yeah, 1 gallon of gas costs $3, right? It's pretty expensive. Got gas for $1.51 the other day. And we are going to totally eliminate this. I ran into issues with it with my A period. So I was like, yeah, we're just not going to confuse you guys. I just want you to be able to understand what direct variation means. It means that we are directly varying between two variables, starting at an origin, so 0, 0, and then we increase. So a lot of the time, and actually almost all the time, these are real life situations that are directly variated. We start at 0 time, 0 money, right? 0 gallons of gas to 0 cost, and so on. Okay? So being able to find a constant is very crucial here. And then there is a problem with the homework. It's the last one specifically that some people are like, I don't understand what you want here. We'll just talk about it in class. But it's to get your mind kind of thinking on how constant variation, slope, and rate of change are all the exact same thing. But a constant of variation is actually in a real life situation, typically. Pretty much always. Okay, so that's all we have for today. And your homework is posted on Formative. Do your best to just fill in what you can there with the answers. And you can talk with the people in your class, okay? And I will see you all on Thursday.